Hello, this is Alex, BuddyEngineer here. I would like to present our new product, which is gas delivery manifold. It is built on sturdy, thick polyethylene. It's inert material. It's not sensitive to wetness or any aggressive media in the laboratory. So, as you can see, the manifold has 3 inputs, 10 outputs, and an exhaust valve. In addition, the manifold has a flow meter up to 1 liter per minute. It has a manometer that measures the pressure in the destination. Very important thing here is a 3-way valve that is switching between pressurizing with your desired gas and a vacuum. It is a vacuum pump. Finally, there is a feature that we're very proud of, is a so-called dead man switch. It's a piece of electronics here that operates a solenoid valve. It will keep the valve open for 25 minutes approximately in case if you forgot to turn off your flammable gas and it is going into your laboratory. It will shut it off right here. Of course, we definitely recommend that you always turn off your flammable gases and use all possible precautions, but still, in case, there is a dead man switch which will have to be manually reactivated after 25 minutes by pressing the button. Here is one thing which may look strange, is that piece of hose. That piece of hose is a proxy for the oxysorb. The oxysorb, you will see it on the final picture. This will be installed in a loop here, and the oxysorb will absorb remainings of oxygen impurities in the gases. We didn't want to ruin the oxysorb, we didn't want to puncture it for our demonstration, so we instead just use the bypass. Final very important piece here is the overpressure valve that triggers at 70 psi, which is slightly higher than the suggested pressure of 60 psi, and will protect the rest of the system from destruction. So now I would like to show how to use the system, pretending that this gas here, it's just compressed air, but it could be hydrogen or a mixed gas, hydrogen with nitrogen, hydrogen with CO2. We set it up here to 60 psi or 400 kilopascals. It's approximately 4 atmospheres. As you can see, this air comes in, but the pressure here is 0 because the dead man switch shuts it off. Let's energize the dead man switch. You hear a brief hiss. The gas flows and pressurizes the system, and you see right here 400 psi. Okay? Sorry, 60 psi, 400 kilopascals. So now we want to pressurize our bulge tubes or any other flasks and evacuate at the same time with vacuum. We turn on the vacuum pump, and the vacuum pump can run on its own. Right now we assume that we connected these spigots to our destination bottles. Keep the valves open. You could hear the gas rushes in, and then eventually it will reach equilibrium, and pressure in the flask will be equal to the pressure in the tank. So to simulate this process, we'll just close off the valve. Okay? And now you could see that there is no gas flow anymore. This means that the system is completely pressurized. Your bulge tube or your flask is fully equilibrated. Now we want to evacuate your tubes because it has air. You flip the lever to the other side, and it will start sucking air out. Let's assume that we have something connected here. You open it up, you can hear how it sucks the air. So again, once the system is equilibrated, you would notice here that the pressure reaches maximum attainable on the vacuum pump. and then you can repeat the process. Pressurize, wait until it is 0, vacuum. Sometimes you might hear this little sound like little whistling. Just jiggle this thing. It's some technical issue with that particular type of valve. It is not a, it's not broken, but it's just the way it is. So you do it several times. Pressurize, pressurize, vacuum. Pressurize, vacuum. Finally, to switch it back to pressurized, make sure the flasks are pressurized. Turn off the vacuum pump, turn off the dead man switch, or alternatively shut off the valves, and you see system keeps pressure. There are tiny leakages, but it's enough to keep it pressurized for a while. Then you open the drain valve, and then you drain it down to the desired pressure, 2.5 atmospheres or 2 atmospheres. So once you reach the desired pressure, you can disconnect everything, close the valves, you're done. Thank you. BuddyEngineer.